Hello, this is Kevin. Welcome to part 4 of my tutorial for the um, Zelle chapter 11 exercises. And what we're going to do now is sort of a variation on what we did for part 1. So let's just take a peek again at what we did for part 1. We have this create state area reports. Okay, and if you recall, we read a file, okay, that had data in it about a bunch of states in the U.S. and it had the land area, it had the water area, and uh, we analyzed the data. And when we created the reports, we we sorted it two different ways, and to be able to do that, um, we needed to put each of the items in a list and then sort that list. So let's just run the test so we can recall what that looked like. Okay, so we're going to run the test, and the data is called state area data dot text, and we run this and we see it sorted two different ways. We have it sorted by state name, and the data is land area in square miles, water area in square miles, total area in square miles. Okay, and then the second version of the report is sorted by descending total area in square miles. And when you look at the total area in square miles column, you can see that it is descending. All right, so that's what we did. And how did we do the sort? Well, we called the sort method of the list objects that we had, and we passed it a keyword parameter called key. So we say key equal, and then we gave it the name of a function. So to sort it the first way by state name, we created a function called by state name. Okay, and then to sort it the other way, we created another function called by total area, and we included the other keyword parameter reverse, and we gave it the value true so that it was in descending order of total area. So this is the way that you give it the sort information, the key information for the sort. What we do is that we create explicit named functions, one called by state name and the other one called by total area, and we typically have them down the bottom. So here's by state name and here's by total area, and you can see that they both are expecting a parameter that is an instance of the state class, and they're going to return the value for sort to use in its sort comparisons. Okay, and it is just the state name field from that instance. Okay, so we use the parameter name state instance dot state name. Okay, and then in the other one where we're doing the by total area, okay, we're doing again, the parameter name is state instance, and so we're doing state instance dot, and here we have to call the method calculate total area in square miles, and we know it's a method because it has a verb-oriented name and it's got the parens at the end. And that's all we have to do to get it to sort. All right, so what are we doing now? Well, we're going to specify these functions using a different syntax called Lambda Expressions. Okay, and uh, let's take a look at what we're going to do. Okay, I guess I got to bring my project back. That's not working yet. Is that going to work? Yeah. Okay. So the first thing that we're going to do is we're not going to change the previous example that we had. We're going to copy paste it and give it a slightly different name. So I'm going to close this. I'm going to highlight the one we have called create a state area reports. I'm going to copy, and I'm going to highlight the name of the project and right click and paste. Okay, and this one is just going to have a few extra words. After the word reports, we're going to add using Lambda, Lambda, sort keys. Okay, and hopefully you'll have heard me talk about these Lambda expressions in class. Okay, and how do these work differently? Well, they are anonymous functions. Okay, so instead of having a name function that does what we're expecting it to do, okay, we're going to have an expression here that has the same code, has the same logic, but it doesn't refer to another function in the program. It just puts the code right there in line. Okay, so Lambda functions are anonymous functions. They're anonymous in that they don't have their own name. They start out with the word lambda. Okay, what does this look like? Well, I want to show you the code for that. Okay, let me go right here. So, here are the kind of changes that we're going to make. Okay, so here is an example of code that sorts a list of students that are created with a custom student class, kind of like the one that was in the textbook in chapter 10. And again, you can see that we're calling sort, and in the keyword parameter, we're simply giving the name of the function that is going to provide the sort key, okay? And then we have a function by that name, okay? And that function is expecting an instance of the student class, and we're calling that parameter student. And then we are returning, in this case, I thought it'd be kind of interesting to sort them by last name comma first name, which is a typical way that you sort a list of people. And so what do we return? Well, a concatenation of student.last name, that's the last name field from the student instance, a comma space, and then student.first name. Okay, and that should work just fine. And then we come back from the sort and we say for student in if students, and then we print each of them. Okay, what does it look like when you convert this to a lambda? Well, instead of naming a function that has to occur within the program, we just put the code in line. So the word lambda kind of becomes a standard name for this anonymous function. Okay, lambdas are they're fairly popular constructs in modern computer programming languages, and the word lambda is used as a way to describe anonymous functions. So we say key equal and we have lambda, and then the rest of the text is the function. The word student that comes right after lambda is a parameter. So we have lambda space parameter list colon, and then we have the code. The code is the value that we're going to return. Okay. Now, are we executing different Python? We're really not. We're using a different syntax. Okay. The syntax for a regular function is we begin with a def, and then we have the name of the function, and then in the parens we have the parameter list, and then a colon, and then we have the body of the function. Typically, the last line is a return, and we have the expression that we're going to return. Now, lambda functions are always short functions like the one that we see here called by last name comma first name. Okay. So what do we have instead of the name? Well, we have the keyword lambda. Okay. What do we have in place of the parameter list that's in the parens? Well, we have a parameter list that comes after the space that came after lambda. Okay, in this case we only have a single parameter, but if we had more than one, we would separate them by commas. Okay, how do we know it's a parameter? Well, because it came after the word lambda and before the colon. Okay, so that combination are kind of acting like the parentheses do on the example above. And then what about the code? Well, if you look at the code that we have here in the body of the lambda, it's the same code that we had in the body of the named function. It's using the parameter name dot field name, and it's doing a concatenation. So it's really just a different syntax. Why do we use it? Well, the reason that I'm teaching it is it's used when people are using some of the big data tools. They are asked to pass lambda functions to the tools as a way of kind of filtering things out and giving sort keys and all that kind of stuff. So this is a different syntax that if you're taking some kind of data analysis class that's using Python with big data tools, you might be asked to produce a lambda. Okay, and I decided this would be a good place to teach it. This is the only use case we have in our course where a lambda would help. Where do we pass a function as a parameter? Well, when we're doing the sort for the list. Okay, so this is the only use case that we have here, but if you learn this and you do it well, you should be able to use this same approach with some of the big data tools that you'll learn how to use in your data analysis classes. Okay, so all we're going to do is that we're going to go from the simple named function-based syntax to the lambda syntax, and it's more compact because we don't have a whole separate function with a header. It's probably a little more terse and hard to read, but the proponents of it think that's okay. Okay, and I probably think that's okay. Typically, the code that we're putting inside of a Lambda expression is this kind of terse code. It's just like this, very short functions. Okay, so let's pull this off and let's do it to the code that we have at hand. Okay, so we're going to get rid of the code in by state name, but let's just steal this. So we have state instance dot state name. Okay, so let's copy that. Okay, and go back up here, and we're going to say key equals, and of course we begin by lambda, Lambda space, and then we have the name of the parameter that we're expecting. Okay, we had been calling it state instance, so we'll do the same thing. State instance colon, so here comes the code, and now we're going to paste it. It's that easy. So lambdas are all about returning values. Okay, so they don't have an explicit return. The implication is that we're going to have an expression here in the body of the lambda, and that's what we want to return. So it's that easy. Okay, so let's look at the second one, by total area. We have to remember to preserve this reverse equal true. Okay, so let's just go down to by total area. And this is a little different. We're using the same parameter name, state instance, and we're calling a method, calculate total area in square miles. How do we know it's a method and not a field name? Well, we have a verb-oriented kind of name. That's our first hint. And then the second one is we have the parens. So let's just copy this code. Okay, going to do a copy here. And let's go up and change the second sort. Okay, so instead of putting the name of the function here by total area, we're going to have lambda. That's the hint to Python that we're using an anonymous function, space, parameter name. We're going to use the same one again, state instance. Okay, colon means here comes the body. Okay, paste that code right there. All right. And then comma, reverse equal true. And that should do it right there. Now, is there anything else that we want to do? Yeah, we want to get rid of the two named functions that we had because we don't need them anymore. Okay, we've refactored. We've actually factored these out and the lambdas in. So I'm going to delete, and we want two blank lines there. Okay, so just to review, instead of naming a function for the sort to call, we are passing it an anonymous function, and anonymous functions in Python begin with this lambda keyword. Okay, let's give it a test and make sure it works. Okay, we've got a duplicate code complaint because we copied a program. Okay, I'm going to right click on the editor and say that I want to run. Okay, and I've got a problem because I don't remember the name of the file. State area data. State area data.txt. And that looks good. So what do we have? Yeah. So when we did it by state name, we're in order by state name, and we do it by descending total area square miles. That's still in the proper order, so that seems to have worked just fine. Okay, very good. And is there anything else that we want to test? Well, we could test it again with the empty file. Okay. I don't think it does anything pretty when we pass it an empty file, but let's see what happens. It's always the last thing you try that runs into trouble. Empty file.txt. Oh yeah, we get empty reports, which is fine. That's reasonable behavior too. So that is it. Okay, we have learned about these Lambda expressions, which again are just anonymous functions, very small functions, like the kind that you use, say, for key information. And again, the Lambda expression has all the parts that the named function had, just in a more terse syntax. And that's the way to think about it. All right, that's it. I'm going to say bye until next time. Bye-bye.